Welcome to the OpenBrIM Platform. In the previous tutorial, we demonstrated how to create an alignment quickly and efficiently using the OpenBrIM Platform. In the next few minutes, we will illustrate how to construct the bridge skeleton once the alignment has been defined. Let us begin. To begin, navigate to the Bridge Geometry category within the tree view and select the Bridge Alignment object. In a bridge project, multiple alignments may be defined. This object specifies which alignment will serve as the reference during bridge definition. Click the three-dot icon button within the alignment parameter. In the resulting interface, select Alignment 1. If required, additional detailed information pertaining to the bridge may be defined by selecting the Bridge Info category. Following alignment selection, click Support Lines in the tree view. A support line designates the location at which a pier is to be placed on the bridge. In this project, 4 support lines will be created: 2 abutment support lines for the bridge start and end points, and 2 additional support lines at the pier locations. Click the three-dot icon button in the bridge parameter and assign the previously defined bridge alignment. To designate this support line as the bridge starting point, click its name field and enter Abutment 1. The station, skew angle, and transverse offset values for this support line will remain at their default settings. For the second support line, click the station parameter and set the value to 160 feet. Then assign the name Pier 1. Repeat the same procedure for Pier 2, with a station value of 370 feet, and for abutment 2 with a station value of 530 feet. The width value of the support lines may be modified by selecting the 3D Visual category. Support lines can be shown or hidden as needed, and their labels within the 3D view may be renamed using the label parameter. The support line definitions are now complete. In the tree view, click the Insertion Point object. Insertion Point objects represent the bearing elements within the project. Click the three-dot icon button in the location parameter, select Abutment 1, and set the transverse offset value to 16.5 feet. For the remaining insertion points associated with Abutment 1, set the transverse offset values to 5.5 feet, minus 5.5 feet, and minus 16.5 feet respectively. Before proceeding to define the next insertion point object, it should be noted that the girders in our project will be configured as continuous. However, to demonstrate how insertion point and girder layout objects should be defined in bridges containing non-continuous girders, we will switch to a prepared example project. As observed in the project, a non-continuous girder layout has been defined at the Pier 1 location. Let us examine how these girder layouts are defined. We open the data spreadsheet and click Insertion Point in the tree view. The insertion points created at the Pier 1 location, where the non-continuous girder layout definition is established, have been assigned longitudinal offsets to enable this configuration. These insertion points are then utilized when defining the girder layout, thereby producing the non-continuous girder layout. Now we can return to our original project. To define the next insertion point, click the three-dot icon button in the location parameter and set the Pier 1 support line. Then, select the transverse offset values from the previously defined insertion points. Right-click and select Copy. Click the transverse offset parameter of the insertion point 5. Right-click and select Paste. To define insertion points for the Pier 2 location, click the three-dot icon button in the location parameter once more and select Pier 2 from the interface. Set the transverse offset value to 0. Before continuing with additional insertion points, we will demonstrate how transverse and longitudinal offset values should be configured when a skew definition exists at any pier location in the project. When working with a support line that has a skew angle greater than 0 in the OpenBrIM platform, it is important for users to specify the transverse offset along the support line, not along the PGL. Additionally, if a support line has a skew angle greater than 0 and longitudinal offsets greater than 0 are being used, the longitudinal offset parameter is applied perpendicular to the support line. Now, click the +Z direction in the orientation indicator at the lower right to switch to plan view. Then, click the support lines object in the tree view and set the skew angle parameter of the Pier 2 support line to 30 degrees. Return to the insertion point in the tree view. For a new insertion point definition, set the transverse offset value to 10 feet. To verify the accuracy of the entered data, click the Measure Distance icon on the screen and measure the distance between the two created insertion points. The resulting interface displays a station difference of 5 feet. This value is calculated by multiplying the transverse offset value of 10 feet by the sine of 30 degrees. The same interface shows an offset difference of 8.6603 feet. This value is calculated by multiplying the transverse offset value of 10 feet by the cosine of 30 degrees. Close the measurement results screen. To examine the longitudinal offset behavior under skew conditions, create a new insertion point and set its longitudinal offset value to 5 feet. To view the station and offset differences for the created insertion point, click the Measure Distance icon again and measure the distance between the two insertion points. In the resulting interface, the offset difference appears as 0 because the transverse offset has not been changed. The same interface displays a station difference of 5.7735 feet. Since the longitudinal offset value is entered perpendicular to the support line, the distance between the two insertion points is calculated as the longitudinal offset divided by the sine of 60 degrees. Close the measurement results screen. Click the support lines object in the tree view and set the skew angle parameter to 0. Click the insertion points object in the tree view and set the longitudinal offset value of the insertion point 11 to 0. Then click the transverse offset value of the insertion point 9, right-click, and select Paste from the interface. To define insertion points for the abutment 2 location, click the three-dot icon button in the location parameter and select the abutment 2 location. Then click the transverse offset parameter. Right-click and select Paste. We have now defined all insertion points in our project. For the defined insertion points, the reference object parameter is set to Girder layout by default. In this project, the default setting will be retained. Additionally, while the reference alignment parameter is set to bridge alignment by default, if your project contains a girder that does not follow the main alignment and you wish to include this girder in your calculations, you may create insertion points with a custom alignment. Subsequently, you may define girder layouts using these insertion points and add the girders to your project through these layouts. To demonstrate how the custom alignment parameter operates, we will switch to a model in which a custom alignment has been previously defined. In the tree view, click Insertion Point. Click the three-dot icon button in the reference alignment parameter of the insertion point 4 and set it to Custom Alignment. Once this parameter is configured, the Custom Alignment parameter will become active for the insertion point 4 object. Click the three-dot icon button in this activated parameter and select the alignment named Alignment 2. Repeat the same procedure for insertion point 8, insertion point 12, and insertion point 16. Following this process, as observed in the 3D view, the girder layout objects have been generated along the custom alignment PGL direction. We now return to our original project. Finally, click the girder layout object in the tree view. The purpose of this object is to generate the line associated with the girder object to be defined within the project. Click the three-dot icon button in the support parameter, then select the Pick option in the resulting interface. From the screen, select the Insertion Point 1, Insertion Point 5, Insertion Point 9, and Insertion Point 13 for the first girder. Then click the Done button at the top of the screen. The first girder layout has now been created. When defining a girder, you may choose to align it along the alignment or define it as a straight line regardless of the alignment properties. This behavior is controlled via the horizontal and vertical geometry parameter. Click the three-dot icon button for this parameter. Selecting Linear Between Insertion Points from the interface will generate the girder layout linearly, independent of the alignment, as shown on the screen. Since the alignment properties are to be used in this project, click the three-dot icon button again and select Use Alignment Between Insertion Points. For the next girder, click the three-dot icon button in the Supports parameter once more. Select the Pick option, choose Insertion Point 2, Insertion Point 6, Insertion Point 10, and Insertion Point 14 from the screen, and click Done. Repeat these steps for the remaining two girder layouts to be defined. The girder layout definitions are now complete. The layouts may be reviewed in the 3D view, and the layout lengths may be verified using the read-only total length parameter. Additionally, by clicking the 3D settings category, the curve refinement of a girder layout may be adjusted. And if cantilever lengths are present on the girder, the initial and end cantilever values may be configured accordingly.